Hello, everyone. My name is Andy Hopper, and I'm a Senior Solutions Architect at Amazon Web Services. A frequent use case for customers running Elastic Compute Cloud, or EC2, instances is to have a way to automatically install applications on these instances. For example, you may have a CI/CD pipeline that builds your code, and you'd like to have the latest version of your application deployed after the build completes. In this video, we're going to explore how you can use one of AWS's DevOps services named AWS CodeDeploy. Now, for those of you who aren't familiar with the service, it's a way for you to have software automatically installed on EC2 instances, Elastic Container Service or ECS services, or even AWS Lambda. For the purposes of this video, we're going to focus on a Windows use case running on EC2. However, if you're interested in performing similar steps on other OSs or platforms, you can learn more from the AWS documentation on CodeDeploy. So, let's get started. What I have open here in Visual Studio is an ASP.NET Core MVC web application. Now, I'd like to point out that while this particular application is using the .NET Core runtime, everything I'll be describing in this video applies to .NET Framework applications as well. You're just going to be using a different runtime for your application. By the way, the source for this application is publicly available in GitHub, so if you want to peek at the code for this, as well as some other videos I'll be recording on deploying .NET applications, you can download it and try it out in your own environment. Okay, back to our application. I'd like this application to be able to launch automatically on boot and stay running. This is an ideal use case for a Windows service, so I've added the NuGet package that supports running a .NET Core application as a Windows service. So, I've got my application. I've got it set up to run on boot, so now I just need to figure out how I'm going to get this to automatically install on my instances. Before I can have my applications installed on my EC2 instances, I'll need to fulfill a few prerequisites. First, I'll need to have the CodeDeploy agent installed on my EC2 instances. This agent is what actually performs the installation on these instances. Next, CodeDeploy is an AWS service, and like any other AWS service, you need to ensure that you have permissions to call it. So I'll define an EC2 instance profile, and I'm going to attach a managed policy named Amazon EC2 role for AWS CodeDeploy. Finally, I'll need to make sure that the EC2 instances I'm going to have my applications installed on have access to the public endpoints for CodeDeploy and S3. To do this, I need to ensure that the VPC my instances are launched into have an internet gateway attached, and if I put those instances in a private subnet, they'll need to have access to a NAT gateway that will give them access to the outside world. So let's go ahead and get things set up. First, I'll go ahead and create the EC2 profile. I'll go to the Identity and Access Management console. I'll go to Roles, and I'm going to create a role. In this case, to make an EC2 profile, we'll pick EC2 for the use case. And now it's time for me to attach policies. Now, as I mentioned, we have a managed policy for CodeDeploy, and so I'm going to go ahead and check the Amazon EC2 role for AWS CodeDeploy. I'll skip past the tags, and I'll give it a name, Core Demo, and I'll leave the description as the default. Okay, great. Okay, we have our EC2 instance profile. Now it's time for us to go ahead and create a load balancer to serve up traffic from our application. So I'll navigate to EC2, and I'll scroll down to Load Balancers, and let's create a new load balancer. In this case, I'll go ahead and use an application load balancer to serve up my traffic. So it'll want a name, ASP.NET Core Demo. It'll be an internet-facing load balancer, and it'll serve traffic up on port 80. Next, it wants to know what availability zones and subnets it's going to be running the ALB out of. And so I'm going to go ahead and check the CodeDeploy demo VPC that I've already created. And I will have it serve traffic in the public subnet in these two availability zones. In this case, I'm not going to use the AWS Global Accelerator, so I'll go ahead and skip to security settings. And I'm not setting up an SSL cert at this time, so I'll go ahead and skip that. Were you setting this up, you would configure SSL here. Next is it's time to configure the security groups. In the VPC that I'm going to run my application in, I've defined two security groups. So I've got a load balancer security group, which allows access on port 80 to 0.0.0.0. And then I have the CodeDeploy HTTP security group that we'll use in our launch configuration. This security group only allows access on port 80 to this load balancer security group. That way, I can run these applications in a private subnet, and there will be no internet access to these boxes directly. It has to go through the load balancer. Next, we'll configure the routing. I'm going to go ahead and define a new target group. And so variations on a theme here, I'm going to name it ASP.NET Core Demo. It's going to be of instances, and I'm going to go ahead and have it serve traffic to port 80, and the health check will just be the root of the application. In this case, I'm not going to register any targets at this point. We're going to let the auto scaling group manage that part. So next, we'll click Review. It just shows us all the choices that we've made at this point, and we'll go ahead and click Create. Awesome. Now we have our load balancer. All right, so for an auto scaling group to be able to create EC2 instances automatically, first I have to give it something called a launch configuration. So I'll go ahead and click on EC2 to go to the EC2 dashboard. I'll scroll down and I'll click on Launch Configurations. And then I'll click on Create Launch Configuration. So it's going to ask me for a name, so I'll call it ASP.NET Core Demo. And then it needs an AMI ID. Now, in my case, I've already looked up the AMI for Windows Server Core, so I'll just go ahead and paste that, Windows Server Full, and I'll paste that in here. Next, it'll ask me a few additional details. So I'm going to go ahead and choose an instance type. This is going to be web application, so I'll go ahead and make this a C5 large. I'll choose that. And then next it's going to ask me for an instance profile. In my case, since I want to be able to interact with CodeDeploy, I'm going to go ahead and choose that ASP.NET Core Demo instance profile we created earlier. Next, it's going to ask us some advanced details. And one thing that I need to do, as I mentioned earlier in our prerequisites, is that I need to have the CodeDeploy agent automatically installed on the machine. So what I'm going to do here is I'm going to use a user data script that I've already written. What this will do is it downloads and installs the CodeDeploy agent onto the machine. And all it's really doing here is I'm creating a temporary path. I download the CodeDeploy agent from the location that we have published in the CodeDeploy documentation. And then all I'm doing is I'm actually running the CodeDeploy agent installer on the machine, and I'm indicating that I'd like for the user data to wait until that CodeDeploy agent has completed successfully. All right. As far as EBS volume size is concerned, I'll go ahead and accept the default of 30, but it is going to ask me what security groups that I'd like to use. Now, as I mentioned earlier, we've got our CodeDeploy HTTP security group, so that's the one I'm going to use for the instances. If you recall, what this security group is going to do is allow access from our load balancer to call port 80 on any instances in the security group. And it's just showing a warning message. I haven't opened up 3389, which is fine. I'm not going to launch these with a key pair. As a matter of fact, right here, I'm going to indicate that no, I am not going to use a key pair for these instances. CodeDeploy is going to be the only thing that will be doing anything on these boxes. So let's go ahead and create our launch configuration. All right, we have our launch configuration. Now it's time for us to create our auto scaling group. To do that, we'll navigate to the EC2 console. We'll scroll down to Auto Scaling Groups, and then we'll click on the Create an Auto Scaling Group button. And you guessed it, we're going to name it ASP.NET Core Demo. And then you'll notice in this case it's asking us to pick a launch template, but we can switch to launch configuration. Since I've defined mine as a launch config, I'll go ahead and switch to that. And I'll pick our ASP.NET Core Demo launch configuration. And you'll notice it's got the AMI ID we picked, it's got the instance type we chose, and you'll also notice that it doesn't have the a key pair associated with it. So let's click Next here. Then it's going to ask us what VPC we're going to launch these instances into. I'm going to choose the CodeDeploy Demo VPC that I've already created. And I'd like these instances to go into the private subnets. I'll let the load balancer live in the public subnet and be accessible to the outside world. Next, I'll enable load balancing, and then it's going to ask me, what target group my load balancer is using. I'm going to select the ASP.NET Core Demo target group that we created earlier, and then I'll click Next. And then it's asking me some information about the sizes and number of instances I'd like. Let's go ahead and we'll set everything to 2 here. So I'll say I'd like to have a minimum of 2 instances just to show how CodeDeploy works. And I won't bother setting up any scaling policies or whatnot. I'll just leave it at 2. Now, this is all where you could optionally configure any kind of notifications if you want to receive SMS or email notifications when auto-scaling takes effect. I'm going to go ahead and skip this here. We'll move to next. And then finally, we have the chance to add tags to our instances. I'm going to go ahead and add a name tag to our EC2 instances, and we'll call this CodeDeploy demo. And we'll click next here. And finally, we just review all the choices that we've made up to this point. And I will go ahead and click on Create Auto Scaling Group. All right, now at this point, what's happening is the auto scaling group is creating the EC2 instances that it needs to actually create. Rather than make you folks wait for this process to complete, I'm going to use the magic of video editing, and I will just see you on the other side after our EC2 instances have been created. Okay, great. So our auto scaling group has kicked in, and it's created the EC2 instances that we want to deploy our application to. All right, it's time to create our CodeDeploy application. So to do that, we'll click on CodeDeploy to navigate to the CodeDeploy dashboard, and we'll click on Applications. So let's create one. And I think you know what name I'm going to use for my application by this point. And then we get to choose the platform we're going to use for our application. Now, this is a cool feature of CodeDeploy. I have the ability to deploy to EC2 instances or my on-premises machines, but it also natively supports the ability to deploy to Amazon Elastic Container Service, ECS, or to AWS Lambda. But in this case, we're going to stick with the Windows EC2 instances that we've already had our auto-scaling group create. So we'll go ahead and click Create Application. And then next, it's going to ask us to create a deployment group. So let's go ahead and do that. So next, we'll want a deployment group name, and I think we know what I'm going to use. And then next, it's going to ask us for a service role. And this is actually, I forgot to mention this in the prerequisites. So let's go ahead and take care of this. In order for CodeDeploy to work, it's got to have a service role that grants it access to invoke the CodeDeploy APIs. So let's go ahead and we'll navigate to Identity and Access Management. And we'll create a service role for CodeDeploy. So we'll click on Roles, we'll create a new role, and instead of EC2 like we did for the instance profile, we'll scroll down and we'll go to CodeDeploy. And then it's going to give us what our options are here. Now in this case, I'll just choose the vanilla CodeDeploy. You'll notice that there are two other service roles, one for ECS and one for Lambda. In this case, I'm deploying to EC2, so I'll just choose the original. Next, it'll prompt us for permissions, and it'll already have the AWS CodeDeploy managed policy attached to it because it is a CodeDeploy role. I'm going to skip the tags. There's nothing I want to add here. But then finally, I'll have to give it a role name. So we'll call this CodeDeploy service role, and I'll leave the description as it is. So let's go ahead and click on Create Role. And great, now we have our new service role defined. So let's go back to the CodeDeploy console. And what I'll need to do is just kind of recycle the page here so it'll refresh. So I'll click Create Deployment Group again. And now I'll get to go ahead and choose our ASP.NET Core demo for the deployment group. But now when we choose service role, our brand shiny new CodeDeploy service role is available to us. Next, it's going to ask us what deployment type we want to use for CodeDeploy. Now we're only going to cover the in-place on this video, but I will be recording another video that demonstrates how it works for blue-green deployments. So let's explain a little bit what in-place deployment does. What this means is if you have an EC2 instance, it will deploy your application to that instance, and as you deliver new application revisions, what CodeDeploy will do is uninstall the previous version of the application from that instance and install the new version to that. And so what it'll effectively be doing is recycling those EC2 instances. Whereas what blue-green will do is it'll spin up brand new machines that have never had the application installed on them and install the application to that. Depending on how you'd like to configure things, you may choose one or the other. But again, for this one, we're going to go ahead and just recycle existing instances with the in place. Next, it's going to ask how I select the set of EC2 instances I want to deploy to. In my case, I've already defined an auto scaling group, so I'll go ahead and choose EC2 auto scaling group, and it then prompts me to select which auto scaling group I'm going to use. In this case, I'll choose the ASP.NET Core demo one that we created earlier. And next, it'll ask me for the deployment settings. Now, this is another really interesting feature of CodeDeploy. You'll notice by default, it's going to deploy to all the machines all at one time. That's certainly the fastest way to deploy your applications to a fleet of EC2 instances. However, that can involve downtime because what it will do is uninstall any previous revision from the boxes and then install the new one. And that does mean that there's a potential for a period of time where none of your application servers have the application installed after it has been uninstalled. If you'd like to have it to where some of your machines still have a revision up and running during the deployment process, then what you want to choose is either the one at a time or half at a time. And those are, as advertised. One at a time will install the application at most to a single machine at any given time. And then half at a time will deploy it to half of the instances that you've specified. So the one at a time is the most conservative, but it will take longer because it'll have to cycle through each machine at one at a time, whereas half at a time we'll do it as a 50-50 process. I'll go ahead and choose one at a time. In my case, the auto scaling group was set for 2, so one at a time and half at a time really are exactly the same, but we'll go ahead and choose that. Finally, it's going to ask me if I have a load balancer attached to these. This is another really powerful feature of CodeDeploy. It's aware of load balancing, and what it can do is remove an instance from a load balancer's target group so that there aren't any false negative health checks. And so what I'll do here is I'll go ahead and choose the ASP.NET Core demo target group that I've already defined. And now we're ready to create our deployment group. Okay, great. So we have our deployment group. Now it's time for us to create an application revision so we can deploy it to these servers. All right, so let's create our application revision for deployment. So we're back in our ASP.NET application. And if you look here, I've taken the liberty of already building the necessary infrastructure to deploy our application in the interest of time. Now, what CodeDeploy expects is at the root of the zip file, which is your application revision, there will be a special file called appspec.yaml. This is a YAML file that includes the instructions needed to deploy your application to your instances. And in this case, what you do is I've specified that this is for the Windows operating system. You can alternately specify Linux. And then what I'm telling it is, where it's going to pull the application's files from. In this case, I'm going to have a subdirectory in that zip file that's called app. And the destination where it will extract all the files in that app folder to is going to be a new folder on the machine called app server. And then what I'll do is I'm actually hooking lifecycle events in the deployment process. So I've got a before install where I'm going to install the .NET runtime. I've got application stop. This is the script that gets called if you ever remove the application in preparation to install a new revision onto the machine. After install, which really means after it copies the files, I'm going to have it register a Windows service on the machine because, after all, I want my application to run when the machine boots. And then I'm hooking the application start event, and what I'm doing here is I'm actually starting the Windows service. And then finally, there's a lifecycle event called validate service. This is a really important lifecycle hook because this is what allows you to cause the deployment to fail if your test doesn't pass. So it's a safety check for you to ensure that your application is actually properly up and running and not giving you a false positive on the install. So let's take a look at what these scripts look like. So you'll notice they're all PS1 scripts. For Windows machines, you can either use batch files or PowerShell scripts. And if we actually look at the scripts themselves, in order, we'll look at install.NET. So this is simply a PowerShell script that will download the latest version of the .NET runtime from Microsoft. At the time of recording this video, that's 3.1.6. I'm checking to see if I've got that version installed on the local machine. If it isn't already installed, then I will download it from Microsoft's website, and then I will invoke the installer. And I'm just telling the start process commandlet to wait for the complete installation of it before it does anything else. Once it verifies that the ASP.NET runtime is installed in the box, then to actually install the application, let's go ahead and move on to after install. We'll take a look at application stop in just a moment. So the after install script, which is register service, this simply creates a new Windows service. I give it a name, ASP.NET Core Demo. That should be pretty familiar to you by now. I'm telling it where it'll find the binary that my service is using. And since this is ASP.NET Core, I'm going to specify the URL that the service is actually going to run on. And you may recall that I'm using a special NuGet package that allows me to run my application as a service. I've actually written my application so that when I see the -- service command line switch, it knows to start as a Windows service. Once I've actually got the service registered on the machine, then I just go ahead and ensure that port 80 on the machine is open so that external applications can reach the web application. Next, I'll go to application start, which is start service. Very simple PowerShell commandlet. All it's doing is just invoking start service on the newly registered ASP.NET Core demo service. And then finally, I've got my validate service. And all I'm doing here is I'm calling smoke test. And this smoke test script simply just invokes a web request on port 80. All I'm doing is just verifying that I'm actually responding to traffic. In practice, what you're probably going to want to do is perhaps invoke a synthetic transaction or something that exercises a lot more of your application to verify that it really properly got installed on the machine. Now, the last thing I wanted to point out was the application stop hook. We kind of blew past that here. And the reason for that is that this actually gets invoked when it comes time to remove the application from the application server. And here's a really important distinction. The application stop event is always called on the previous revision. So I'm writing an application stop here where I'm removing the service. What this will actually do is it knows how to remove the current revision of the application. So what you don't want to do is write a stop service that knows how to clean up the prior version. You're always delivering the necessary script to remove the current revision. So always keep that in mind. If you have more than one revision deployed to an EC2 instance, the stop service is always going to get called on the previous package, not the package that's currently being installed. Okay, great. So I've got my Appspec, I've got my scripts. Now what I want to do is actually create the zip file, which is my application revision. And to help with that, I've actually created a PowerShell script called create deployment. Let's go ahead and walk through the steps of what's actually happening. This will be exactly what you do inside your own CI/CD pipeline. So first, I'm calling .NET publish, and I'm just telling it that I want to use the release configuration. Next, I'm creating a working folder that will hold the contents of my application revision, because remember, we're going to zip this all up together. So I created a new folder. It's called deployment. And then I'll CD into that deployment folder. I will copy the contents of this CodeDeploy folder, the one that has my Appspec and my scripts for the lifecycle hooks, into the root level of this deployment folder. Next, I'll ensure that I have my app folder, because after all, remember, my Appspec, I'm telling it that I want to copy the contents of my application from an app subfolder. Then I'm copying everything that got built into the publish folder into that new app subfolder. And then finally, I'm just ensuring that if I had a previous version of the zip file, I want to blow it away because I want to make sure it's a clean file. And then I'm using the compress archive commandlet to actually zip everything together. All right, so let's go ahead and execute this script. So we'll call create deployment.ps1. And what this is doing now is generating a build of my application. And then it is zipping everything up into a new zip file. And once the archival process is complete, we'll just crank this open inside Explorer just so we can take a look at what the contents of this file looks like. So we'll look at deployment.zip. And as you can see, I've got that appspec.yaml. It's at the root of the folder of the zip file, because remember, CodeDeploy must see this file at the very base of your zip file. I've got the scripts that includes all the lifecycle hooks that I'm using to actually register the application and to smoke test it. And then finally, I've got the contents of my publish folder to just deliver the actual binaries of the application. Okay, so now it's time for us to actually deliver this to CodeDeploy. All right, so let's actually deliver this application revision to our CodeDeploy application. Now, CodeDeploy expects the application revision to come from an S3 bucket. So let's go ahead and create an S3 bucket that'll host the revisions we're going to deliver. So we'll navigate to S3, and we'll click on Create Bucket. And we are going to go ahead and create a bucket for the application revisions. And we'll click Next. And that's all we're going to really need to set. We don't need to set public access or anything like that. So we'll go ahead and click Next and create bucket. And now we have a place to actually host our application revisions. So let's navigate to our ASP.NET Core demo bucket, and we're going to upload our deployment file. So I'm going to navigate to the folder that's actually got my, there we go, ASP.NET Core deployment samples, deployment.zip. And I'll go ahead and click on the upload button. And in just a moment, my revision will be ready to deploy to CodeDeploy. Okay, great. So let's go ahead and click on Services, and we'll navigate to CodeDeploy. We will find our application. We'll click on ASP.NET Core Demo. We'll click on the Deployments tab. And what we're going to do is we're going to create a new deployment using this revision. So it's going to ask us what deployment group we're going to deploy this to. We're going to choose our ASP.NET Core Demo deployment group. And then it's going to ask where our application revision is. So we're going to tell it that it's in an S3 bucket. It's ASP.NET Core Demo. And then it needs to know what the actual key is. So it's deployment.zip. And then it asks for like an optional deployment. I'll just call this something like first deployment. Ooh, if I could spell. Next, it's going to ask for some additional deployment behavior settings. So I can have it, specify any kind of event failure rules on, whether or not the overall deployment is going to fail, or if something, what to do if it tries to unzip the contents of the file and there are existing files already on the box. In this case, I'm going to go ahead and stick with the default configuration for my deployment. So I'm going to go ahead and click on Create Deployment. And now what actually happened is I've now got a new deployment ID, and what's happening is the CodeDeploy agent on the instances, on the two instances that I've created with my auto scaling group, they're informed that there's a new application revision to be installed on the machines. Now, if we look down here, what we'll see is because I selected the one at a time deployment, is currently deploying the application to one of my instances at a time. Now, I'm not going to make you sit here and wait for the full deployment to actually complete, so I'm going to use the magic of video editing to fast forward in time, and I'll just see you on the other side. Okay, it's been a few minutes and our application has finished successfully deploying. So let's navigate to our application load balancer and let's verify that we can actually reach our application. So we'll go to EC2 and we'll go to load balancers. And we'll click on our ASP.NET Core demo and get its DNS name. Let's open a new tab, paste this in here. And there we go. There's our application successfully deployed. All right, so the last thing that I just wanted to mention about CodeDeploy is that it also works very well with our other DevOps services. In particular, there's a service called Code Pipeline. And what Code Pipeline is capable of doing is building a CI/CD pipeline that can fetch your application source, can actually build it. We have a build agent service called Code Build. And once it's successfully built the application, and it could do the exact same set of steps that I did to create a deployment package, you can then invoke CodeDeploy to deploy your application to your infrastructure. So what did we accomplish? Well, hopefully by now you can see that CodeDeploy is a pretty powerful service in the portfolio of AWS DevOps services, and you can use it to install applications on your EC2 or even on-premises machines. Now, that's what we focused on in this video. However, I should point out that CodeDeploy also supports deployment to our Elastic Container Service or ECS service, as well as to AWS Lambda. We also looked at how you can write custom scripts that are used inside your application revision to customize how your application gets installed in a box. And it can do things such as, modify the configuration of the local machine, as well as do things like register daemons or services. We also looked at how you can write custom scripts to verify that your application was properly deployed to a machine so that you have the ability to cause the deployment to fail if it turns out that a smoke test were to not succeed after you deploy the application. And then lastly, we just talked a little bit about how CodeDeploy integrates with other AWS DevOps services such as Code Pipeline. Well, thank you very much for watching, and we cannot wait to see what you build on AWS.